Okay, so first thing we want you try to understand the software. You don't have to write everything in the program. The one I already uploaded to you, that covers everything. Only thing is you need to spend time to understand, okay? This is the one I already uploaded. Okay, so now I will be talking about how can you do it with your project. Okay, first thing you can go to the visual. And you know that will be a new project. Okay, and you say dlab13, for example. Okay, then you say, okay, you can select where you try to save your project. However, I don't care now. Say okay, and will be night. And mark that one. Finish. Okay, right click, add new item. Okay, that will be C++, that's correct. And you can say dlab '19. Add. Okay, so the program will be ready for edit. And now, last thing we have to do here, property. Okay, and common language, CLR, apply. Okay. Okay, so first thing, go into the sample, I sent it to you. Okay, highlight that one. Okay, until end math. Control C, copy. And now you can paste into your project. Okay, so at least you know how to changing something in here, like programmer name. It's your name, it's not mine. Or the version date, any date, like today. This is just a function prototype. I already gave it to you. Okay? And this will be an array for 43 data and value expected. You don't have to do anything here. Okay? This also you need to change something like version date. Okay? And the name, your name is not my name. Okay? And the test program will be dlab13. Okay? And now go to the test number 1. Okay? This one I already did for you. Title, math data, peak of expect data. What I put a comment here. I said send serial data 0855 to E1. Then you have to call this function. Any data you want, 55AA, FF or whatever. And in here, the next line I said, enable function to route input U3 to output of U3. So what you need to do, you have to say enable. U3. Okay? If you see up here on the top, make sure you get the right name. See that? Enable U3. Okay? Now, we say read data proceed. This one is mine, not you. So don't get anything. Okay, so that you done. Test number 1. And the test number 2. Okay, this is the title in Excel. Expect data, now you want AA. And you see the comment send serial data AA, you want. So you better copy from this one. Control C, copy. And you can paste to test number 2. Enable U3. Then you can copy from up here. Enable U3. Copy. Paste them out. So that means you're done for test number 2. This one is mine, so don't try to change anything. Test number 3. The test U5, U6, U8, U9. Data 55. Peak of, I already gave it to you. Expect 55. Now you can say, first thing I'm telling you, send serial data. Okay, 55. So you know which function you call. Okay, then you enable U3. And the next, I telling you, call the function clock to U6. So you can go up here, you can see, to make sure you get the right name. U6 clock. You can copy that one. Okay, then you can paste here. U6 clock. Then enable U5. Then you have to copy enable U5. I can type in, okay? If I already know, enable U5. Okay, then you go to reading that my software. So don't worry about that. You're done for that. I think number 3. That number 4 will be the same. Like that number 3. Okay, you can copy from that number 3 to that number 4. Only thing the data now will be AA, not 55. So that will be done for that number 4. Okay, now that number 5. That memory is 7. Data 55 at the location AA. Expect 55 math data because in here we already say first thing you need to write to memory address AA. Go into write to memory address. Write to memory address right here. Okay, copy that one. Okay, take them out. Okay, that must be changed to 0x AA. Okay, then next one, write to memory data 55. So basically, I can copy that one, change to the data, paste in here. Write to memory address, now change to data. Okay, 55. Okay, then the next one, they say, okay, and also they say write to memory. So you need to call the function write to memory.
Test number 5.
Okay. Then you just go to the next one. Write to memory address file. So copy that guy. Change it to file. Write to memory address data AA. So copy, write to memory address data. Change it to AA. And now write to memory. Copy, write to memory. Okay. Now, reading memory. So the first thing they want to reading from location AA. Okay. Then you just go read memory. That's the function. Okay, that's number 6. Okay, they want to reading data from location 55. So they say read memory. Okay. So that will be done for test number 1 to test number 6. Okay, then what happened here? What is it here? After they run it, that 1, 2, 3, 4, 5, 6, then they go into the function test memory ADC data. That's a function. After they done for test memory ADC data, then they will be go to another function, what we call a test ADC. And after they done for test ADC, they go to another function, complete test memory. Okay, complete memory test. That will be done. So on the test memory ADC data or test ADC or complete memory test, I already given to you everything. Okay, you just copy that, paste to your program. Basically, not much thing you have to do it. Then will be done. And the next one, after the end man, then now we're talking about the function definition. That will be telling you any function in the prototype. That means from here, function prototype. So that one, you must get the function definition. Otherwise, you get an error. Okay, so up to this point, you get any question? We try to make more easy for your test program. What's your job at work? Basically, you don't have to write the program. However, you have to run the test to test the circuitry, and if they not pass, then your job mainly will be fix the problem. That's what we're talking about, troubleshooting. Okay, so any question again up to this point? If it's not, now I will deal with the function definition after the main. Here, from here. Okay, so go into the one I already given to you, uploaded already. From here, go to the end. Okay, Control C, copy. Okay, and now you paste them out. So basically, let's see what you have to do on function definition. Okay. First one, serial data. You don't have to do anything. I still keep it the same. Enable U3. Now, in here I say, edit here. If you want to know, you have to looking for Excel. Okay. Let's see. Here is the Excel. You see that? Enable U3. You need to do a drive to port B, data 0800. Okay? So basically, you have to do a drive to port B. Okay? 0800. So my column. That means you're done for the enable tree, U3. Go to the next one, enable U5. They say edit here. If you're looking into Excel,
Mr. Pham, I hate to bug you, but Maybe you wanted to leave it that way, or maybe you didn't, I don't know, on the enable U3.
You're talking about enable U3, right?
Let's go back.
Okay.
Okay, 0x00, comma 0.
Oh, sorry. Thank you, sir. See, I also comment 0.
I thought you made the mistake on purpose.
No, sometimes I same your guy. Okay. However, you understand, sometimes I still memorize this way. When we write the software, okay, when I say write to port B, I know which one will be capital, which one will be not.
No,
I
figured you were trying to train us, so sometimes you might leave a semicolon out or leave something out deliberately just to see if we understand.
Yeah,
and that makes sense. That makes sense.
That makes sense. You understand, but maybe some students not get along. Okay, then there can be a problem. I try to get as much as I can so they can get this program completely. Only thing is they need to build the circuitry and test, make sure they pass. That's it. I believe during a 2 months for the summer, they can finish all of the lab if they want it.
Well, thanks a lot, Mr. Pham.
You're welcome. Okay, now enable U5. Also, they say edit here. Okay, and if you're looking into enable U5 0x02, okay, then better copy this guy and paste them out here. And change to 0x02. Enable U16. Enable 16. Write to port B01. Okay, so basically, I paste the one, I already copied it. 01. You see how easy to do it. U for large. Okay. See what happened. U for large. Okay. You have to write port B 00. Port D 17, 15, 17. Okay. So okay, create a clock. Okay, add it here. You have to write it 3 times. Control V. I tend to write to port D. What data? (17, 15, 17).
17.
Yeah, 17. Okay, then copy that guy. Copy, paste here. Copy it here. And that will be 15. Okay, U6 clock. So look into U6 clock. U6 clock 04, and the other one will be the same. Okay. Write to port B04. Okay, and now you need to clock the same like the other one. So I can copy that one here. Okay, U10 lot. Okay, right to port D, 0E. Apply negative clock. Just copy and paste, not too much thing to do. Add it here. Will be 04, I think so. Okay. Write to memory address. So this one, you don't have to do anything. I say send serial data, enable E3, E4 lab. Okay. This one don't have to do anything. We get everything for you. Write to memory. Okay. Okay, write to memory. Anything else? No, write to memory. Read memory. Okay, let's see what they said here. Go into read memory. Write to memory, okay. Write to memory data. Write to memory data here. Okay, nothing changed. I go to write to memory. Okay, this is the same. Okay, good. Read memory. You get 08, port B, 10. Okay, so basically this is still missing. Add it here. Add it here. Okay, so the first added will be port B, 10. I can copy that one. Change to port B. One zero, I believe so. And port D. Okay. I copy that guy. This will be port B. And it will be port D. Let's see what port D, 0E. Okay, now I can explain to you a little here. When you want to read memory, read, if you're looking into here, pin number 5, memory output, you want it to be 0. Memory write, 0 will be write, 1 will be read, so that's why 1. Okay? And ADC write, we don't care much, that will be 1. USB, you have to be 1. Memory enable will be 0. So that's why you get 0H, 0E. Enable is 5. Measure data. Okay? That's my, not you. So you don't have to do anything. Okay? Enable ADC. You don't know. Go into Excel here. They will write to put D 3 times. So I copy put D 3 times here. Only change the data. Okay, if you want what the data, you go here, 0E, 0A, 0E. So 0E, 0A, 0E. Okay, get memory ADC data. You don't have to do anything. What is it here? Okay. That's just extra line, we don't need that. This function also, you do nothing. And the last one, you don't have to do anything. We already did it. And now you compile, build. Okay? To see if you get any errors. Okay, now, let's see if I try to run debug without. What's going on? Okay, I also try to explain to you. When you run it, they're telling you fail. Title, test number 1. Test is 1, 2, 3, 4, 3, 8, data 5, 5. Expected data, that means what you want. When they measure the data, they get on 0, so that's why it failed. This is a run without the hardware. So that's why the computer will be read 0 all the time. Okay? However, that will be telling you if they read 0, 1, 0, 1, 0, 1, 0, 0, they're telling you the last bit will be failed. That will be helping you to troubleshooting. Okay? Now let's see. On that one. Okay, that is the test number 1. You see that very simple thing. Send serial. 8-bit serial to 8-bit parallel. That's a function serial. Okay. And then you enable U3, that means U3 1 and 19 0. Whatever input will be equal output. And that output going down here, go to U2 and go to port C so they can read and tell you verify. So, for example, if you get it wrong on pin 18, instead 0, they get 1, or 1, they get 0. Okay? If you wanted 1 in here and they get 0, that means you know that it's wrong. You can easily to using your meter to measure pin 2, U2. If you get 1 here and you not get it, pin 18 is 1, what you have to do, just make sure U2 pin 1 and 19, they must be 0. Okay? If they 0, 1 and 19, you get pin 2 is 1, but pin 18 not 1. What can you do? You're telling me what can you do? If you're telling me, right, that means you know how to troubleshoot it.
You mean like pull the wire?
Now, right now I said, you measure U2 pin 2. You get logic 1. However, we measure U2 pin 18. You get a 0. You know wrong. So what you need to do is check U2 pin 1 and 19, make sure they connect to ground. Measure will be 0, 0 volt. Then what can you do?
You can work backwards.
No, that's not the right one.
You don't go back to U318?
No. You already know the pin U2 pin 2, you want it to be 1, correct?
Correct.
Okay, then pin 18 have to be 1.
Correct.
They not 1.
It's 0.
Yeah, doesn't matter what they get, but not 1.
Right.
You say, okay, I take U1, U2 pin 1 and 19, make sure they're 0. Okay?
Right.
What next you want to do?
And change the IC.
Exactly. Then what I see?
U2.
U2. This is what technicians need to know how to do. That's what we call troubleshooting. Now, when you measure pin 18, you get 0. And then you measure If you pin 2 on, so you get 0. What next you want to do?
Are you saying that pin 2 and pin 18 are supposed to be 0?
Supposed to be 1.
Oh, they're supposed to be 1. Okay, well, if they're supposed to be 1, then to me, Mr. Pham, I think you should go back and look at U318.
Okay, now you go. U318, okay? When you measure, either you get 0 or you get 1.
Right.
So, if you get 1, what happened?
Okay, so let me just say this. U2 pin 18 and U2 pin 2 are both 1.
What 0?
I'm sorry?
Both is 0. So that's why some wrong. You want it to be a 1.
Oh, yeah. Okay, then, well, you got a bunch of wires hooked up, other wires hooked up there, so you got to do some further checking there.
Now,
Then you
see,
check the pin 18 and
Okay.
pin 2 U3.
pick U318
Mhm.
and you get a 1.
Right.
What can you do?
Okay.
You check the input pin 2 U3.
Wrong.
Wrong?
Already get a 1, get the right one.
enable.
Why you take back?
Oh, see. You check the pin 1 and 19.
That's wrong.
Wrong?
Well, it could, because U2 and U3 also hooks up to, I can't see it, they hook up to other chips as well. And you got to make
Oh, yeah?
sure that you're not getting a voltage from them that's being imposed on 2.
No, you're taking your socks. I don't know.
No, okay. I try to tell
Oh,
you.
you have to go in, please. Let me cut this salmon and then you can put the trash over in there.
I'll be leaving like.
Hey, Mr. Pham, mute her mic.
Yeah, just a minute. Now I repeat it. You want pin 18 to be logic 1. Right?
Right,
But you measure, you get a 0.
right.
Then you take input pin 2, you get the same 0.
Right.
Then you go back to pin 18 U3. You get a 1, that's what you want. You're telling me, what can I do?
As it goes toward U2 pin 2, is either got grounded or somehow there's a wire that leads down to another IC or something. I can't see it because you
Then
only
you
got.
try to explain, but what I try to talk to you, take the action. What can we do? That means you say, okay, I'm using the meter to do what? Okay, I can tell you one thing. That may be pin 18, the wire here, not go into pin 2. Correct?
Correct.
How do we take it out?
You pull the wire
Oh,
No.
and check
measure, right?
directly on the IC.
Okay. Set your meter to the ring.
Okay, then you want to turn off the power and ring out the wires?
Ring out on that wire. Okay?
Well, but also, Mr. Pham, as I said before, U2, U3, and I can't see which other one that's, maybe it's U6 or something, but you got to make sure that they're not interfering with what you're doing.
No. I try to repeat again. You know some wire will be going wrong. from
Correct,
18 to pin number 2.
correct,
Correct?
correct.
That's what I said. Set your meter to the ring. Okay?
To check for continuity,
Exactly. Turn off the power.
right.
One connect to 18. One connect to pin 2.
Mhm.
They're not ringing. Right?
Okay, if they're not ringing, then that means another wire is hooked in there somewhere.
So that means the wire will be going drop
Correct,
or missing, go to pin number 2.
right.
That's how can we fix the problem. That's not applied for pin 18. Can be applied for any pin 11, 12, 13, 14, 15, 16, 17, 18. Do the same way.
Mhm.
We don't want to look into the wire after you build. By measure, that will be telling you what wrong, where wrong.
But in this case, you said we should ring it out?
Yeah, you have to ring it out
Mhm.
and check. Now you can check the wire. You're looking into L2, F2, any wire or not, maybe no wire. Okay? Or maybe the wire going something somewhere, not the right. Then you
Not-
can fix it.
Okay, yeah, yeah.
That will be telling you for this test. Okay? If you know how to do it, then they will be done very quickly. Look into the method. Okay? The method here. If you want 1, they did 1, okay. 0, they did 0, okay. And if bit different, that means you know what's wrong. Bit number, first one or second one or so on.
You check the bit that's wrong.
Right, exactly. The thing is, before, I don't have enough time, so I never go into the detail for troubleshooting. But this time, I'm not emphasizing on the software, but emphasize on when it fails, how can we fix it? That's what your job requirement at work. More you do, you get along. That will be helping you to deal with any situation. Okay? And now that number 2, they already failed. That will be the same.
Mhm.
Okay. On that number 3, okay, they test U5, U6, U8, U9.
Mr. Pham,
Yeah,
can you explain one more time the measure? The bit 0, 0? I don't understand the bottom one.
on the bottom one here,
Yeah.
what I say is, right now I'm running without hardware. So the computer read all the time will be 0. If you're running with the board, they will be telling you if they fail, which bit will be not the same, like expected data. So you don't worry about measure data at this time.
Okay.
The thing you know hardware.
All right.
Okay. Now, U5, U6, U8. Let's see, U5, U6, U8. You can see how the signal go. Okay, basically they send the data here, same thing, 55. And they go to output U355. Okay, then this data will be go to U6. Okay, then output U6 here, connect your input U5. Then the output U5 go to port C. You can verify. Okay, U1, U3, U2, we already done. So right now, anything wrong can be, see what I see. They can be U6 wrong. They can be U5 wrong. Also, they will be related, okay, into
U721.
21. That's right. That's supposed to be 0. Okay. And U9 here, pin 11. That means you need a clock for U6 pin 11 to loading data into U6 8-bit. Pin number 1, U6 0. So they will be output here. Okay, when the output here go to U5, and the U5, in order for input to the output, pin 119 must be 0. And they coming out from U8 pin 6 right here. Okay, so anything wrong can be U5, U6, U9, and U8. So in order to troubleshoot it, first thing you write data 55. So 55 will be right here. No problem. The thing is U1, U2, U3 we already tested. So the data already right here. What you need to do, pin 3 at the logic 1. The thing is 5. So when you measure pin number 2, they must be 1. Okay? Now, if you measure U6 pin 2 not 1, tell me what can we do?
Well, I'm gonna try one more time, Mr. Pham, 50-50. Pull the wire on 2 and see what's coming out.
What do you mean 2 and 3?
No. I didn't say 2 and 3. I said, you said it's 1 and it's 0 there. So
No, it's not. Okay, what I'm saying, U6 pin 3, you get a 1, right?
right. Mm-hmm.
And you measure U6 pin 2, they must be 1.
1, but it's 0.
But they're not 1. I don't care 0 or whatever. But they're not 1. Then what can you do?
You could. Oh, it's not 1.
That's just for single IC. You get input, it's logic 1. How come output is not logic 1?
So everything else is okay, except for pin 2 is measuring wrong.
I don't know. But right now I'm talking about pin number 2.
That's what I'm talking about. So you're saying right now,
You have to check the pin clock. pin 11.
The clock and, yeah, the clock and well,
clock.
check,
Okay.
check
Now,
1 and 11.
yeah. If you measure pin 2 to not get logic 1, what you can do? Check pin number 1
One.
and 6. Make sure they be
Zero.
0.
0.
That's the first thing.
Right,
Second thing, you make sure you get a clock L6 pin 11.
right.
And
They have to be 0 to 1.
Mhm.
0.
Pin 1 makes the data go to the output, but the clock makes it actually go.
Yeah. The clock will be loading data inside.
Right,
L6 pin 1 output control.
right,
0, they will be go out.
right.
Okay. Now, if they not output here, it's not right. Input you get a right, output you not get a right. Go check pin number 1. Make sure they 0. Check pin number 11. That means L9 pin 2. Okay. Whatever L9 pin 2, you will be the same L6 11.
Logic.
That should be like a logic 1, because on the U8 pin 12 is you should get a 0 out of there. And once that 0 goes through the inverter, it reverts over to a 1.
Okay, correct. That means you take to pin number 2. You make sure they be 1
Right,
and go back to pin number
1.
3.
Pin
They
three,
have to
three.
be 0.
1.
0.
Number 1, Miss.
number 1's got to be 0 if 2 is
Yeah,
going to
it's
be 1.
number
That's
3.
that's an inverter.
3
Yeah.
have to be 0.
Right.
And you go back to here. Pin
Number 12.
12 must be 0.
0.
Okay. Now, if you get everything, pin 1 okay, 11 okay, but the output is wrong. Wrong on pin number 2, for example. What can we do?
I want to say change the
Input
IC,
the right.
but I got a feeling maybe it could be even grounded. That one
No,
pin.
don't telling me what you think. I'm
Okay.
asking for the action. Tell me
Mr. Pham
what
said no
you
guessing.
do it.
Okay,
First, the input's right, and we check the output control right, the logic was 0, and the clock right, and the U8 pin, U9 pin 1 is
No, we
the right.
already did it.
Then we change the IC, or we check the connection. Pin 2, U6 connect to
Okay, now,
pin 5.
change the IC.
before
Yeah.
you want to change the IC, at work, then you change the IC.
Right,
However, right now you in the lab, you connect the wire. The wire wrong can be cause the problem, correct?
correct.
Right.
Okay, now I telling you what to do. You remove the wire at L6 pin 2. Lift it up.
That's what I said. Check.
Oh, yeah.
That was my guess.
And measure at the
Yeah.
pin number 2.
Yeah,
If you
Wow.
get a logic 1, I can telling you your wire here must be wrong.
you're saying, Mr. Pham, you're saying actually measure on that pin.
On the
And to
wire
measure,
up.
we want to telling you one thing. I say measure L6 pin 2. You have to measure on the pin
Right,
of
right,
the
exactly.
IC.
Exactly, right. Because that's the whole point of pulling the wire.
Yeah, that means that wire maybe go wrong.
Right,
Okay. Now, if you get a logic 1, you know the wire is wrong. You can do the same thing. Turn off, ring the wire. Correct the wire. Where they supposed to go.
Mhm. Hey, Mr.
pin.
Pham, as you were saying, if you're working for a company, you wouldn't pull in the wire.
No.
You can't do that. You can't do that.
Yeah,
Because if you're doing, you would damage the board, right?
right. You cannot lift any wire.
That's we only do that while we're in your class.
Right. The thing is, in the class, you build it.
Right, right.
However, in the company, the wire run in the middle of the circuit board. You never see.
You pull a wire at the company and they fire you, right?
Cannot pull. The thing is, you didn't see any wire.
Mhm.
Only
Okay.
thing is, you measure input is
And
right,
we check the
output is
connection.
wrong. Then you see.
Okay, thank you, Mr. Pham.
Yeah. Okay. So now we go up to U6 output. Then you know they will be go into U5. So now if you measure pin number 2, U5 they supposed to be 1. Okay. And they go to the output pin 19 must be 1. If pin 19,
You mean
18,
18.
not 1. Make sure pin 1 and 19 must be 0. Okay. Same thing. You can leave the wire at pin 18. Try to see you get logic 1 or not. If you get logic 1, the wire here must be wrong. If you still get a 0, okay, you not get a 1, like the input, then you find. The thing is, I go through with your guy, few times, then you can get along. They're very good for technician need. When you run your test, they fail. You know right away what to do to fix the problem. That is successful for the program. That's what you normally do at work. Okay, any question for U5 and U6?
Mr. Pham.
Okay, and the last one I talking this time. Next time we'll be going to the rest.
Hey, Mr.
Mr.
Pham, somebody was trying to ask you a question.
I have a question, Mr. Pham.
Go ahead.
If a IC possibly has a problem, and instead of pulling wires or removing the IC,
First thing you have to remove the wire first.
well, that's my question is, like say if I wanted to run a test on the IC, would it work if I had an IC in a breadboard, just by itself, separately by itself, and I was able to jump each pin to that working IC to complete the circuit, to bypass the IC that's not working on the board, but to have an IC completely separate from the board itself? Would there be a potential connection issue if the IC on the board was bypassed to the new one? Would there be a confliction?
I understand what you're saying. You can get the IC itself, correct?
Well, if you can't take the IC off the board, just have a IC separate.
Okay,
Ready-
now,
ready
if you
to be-
cannot remove the IC,
Right.
that means I will talking about at work.
So
Okay,
if we,
at work you not deal with the wire.
right,
Okay, only thing what you need to do, you measure in input pin 2, you get 1. pin number 18 do not get 1. Your job will be check pin 19 U5 must be 0. Then the U5, that's it, nothing else.
Right, because of data reference on the documentation. You should be always referencing the documentation or expected data. Your test results, basically.
Right. The thing is at work, you have to run the test program. The test program wrote by engineering. We did it. Only thing is if you run the ball working, they pass. Something wrong, they fail. And now you have to fix. But what I'm saying is, in the company, you never care about the wire. Now, if you measure pin 2, logic 1, pin 18 must be 1. They not 1. Then you guarantee pin 119 have to be 0. 119 0. So normally you will be 10 U5.
Hey, Mr. Pham, also,
No, hold on.
okay, go ahead.
You will be 10 U5. Now, the next thing could be happen. You change the new U5 and they still be 0. What can you do?
You have to check to make sure your wiring somewhere.
No wiring. I'm talking about in the company. You cannot check the wiring. The wiring, you cannot see it.
Okay, so you checked 1 and 19, and 1 and 19 was okay.
Right.
And then, but the logic that you got at pin 2 and pin 18 is different.
Exactly.
So then my answer to that is change U5 or notify or notify engineering if there's another problem.
Not yet. Your job still. That's what I asked you. You take U5 pin 2 logic 1. You take U5 18 logic 0 or not 1.
Right.
No, wrong. You take pin 1, pin 19, 0. Then you say, okay, I need 10 U5. Okay? After the 10 U5, still not fix the problem.
Well, like you said, you can't pull a wire, and
you cannot pull the wire.
Okay, that's what I'm saying, Mr. Pham. You can't pull the wire, and you've already made the necessary checks. So at this point,
then we check the connection.
No, not connection.
No?
No,
nothing. You cannot do anything with the connection.
Well, okay. Then you have to notify engineering.
No, I said you're not done yet.
Well, if the continuity of the wires didn't burn, then it has to be software.
No, they already passed. You cannot say, okay, I'm telling you what's going on in the company. When they run the board, make sure they pass.
But they didn't pass on this one.
Hold on. Yeah, they passed everything. Okay. Then they ship to the customer. And the customer will be using. After that, they get a problem. They send it back to the company for you to fix. Okay? So nothing wrong with the program at this time.
Well, then there's got to be a problem with the wiring, but we're not allowed to mess with that.
No, you have to find out.
Well, if it's current,
nothing to do with the current.
Well, I was gonna say, if it's current reliant, it could be power source.
I know for sure you guys cannot.
Mr. Pham, the only other thing it's got to be is that the thing is shorted out, is shorted to ground.
It's exactly sort it out. Okay. Sort it out. Normally, they not sort to route, but they can sort to pin 17. Two pin next together. The
And that-
soldering, you get a soldering problem.
So, so in
They
other
can tie
words,
together.
so in other words, pin 18 is getting the logic that pin 17 got.
Exactly.
But
That
it-
means when you connect 5 volt to route, you get 0. They
That's a-
sort it to route.
that's a question of visual inspection before. it's sent to
Exactly.
customer.
Exactly. In this case, you have to turn over. In the back, you see the pin 17, 18, is it they connect together.
So we go with what Lowell said, take it back to inspection and control and have them relook at it.
Now
But the-
you look at first.
Well-
But the complication is, if it's a visual inspection, you have to also question, why did it pass? So then that becomes
Yeah,
software.
if you find out 17 tied to 18 for the soldering, give it to them, tell them, okay, try to make sure 17, 18 tied, not tied together. They fix it for you.
I just tell them Mr. Pham told me to do.
That means when you troubleshooting, you have to deal with anything.
Hey, Mr. Pham, on top of that, remember that one you told us, okay, you took it to inspection and control, and then they changed the IC, it didn't work. So it didn't work. You took it to the lady who changes the thing, it didn't work, and it happened like twice in a row. What do you do then?
What do you mean?
You have to
You-
say,
You guarantee it did not connect to the route, right?
I'm saying, what if the same problem happened twice in a row with the same
You
unit?
cannot be tried. You cannot try. Only thing is 18 can be tied to 17. The thing is two pin next each other.
I understand.
So they soldering can be make it tie together.
Mhm.
So you just bring it out. Connect pin 17 to 18. If they ring it, you know they tie together. And let them know. Assembler people will be remove that. Okay?
Well, you know, like you're saying, Mr. Pham, depending upon the equipment that's building a board, they can put the component and then test it with no manufacturer assistant or employee testing it, just be the machine. Then depending upon how the machine is designed, it could do a visual inspection, but if it doesn't have visual inspection, that has to go from the machine to somebody visually looking at it and finding out what the problem is.
Yeah, normally that will be hard to happen. However, to me, in the past, that would happen. Not hard to do it. You can turn around the wall, looking for pin 17, 18. You see very clear. They cannot tie together. That's okay. When you genify, they must be working. And if you genify, they still the same. Now you need engineering to help you.
Well, then to be in that ground state, it wouldn't be allowing a reset possibly of the circuit, so
No,
that the product can restart back up. That's
no,
why that's
I talking about 18 and here 17.
no, I understand, but then that's a specific state of that that device or that thing that's having the problem. So if it completes the test, you would think that if it does pass, but it has that final output as far as the digital sequence, it should go into a reset and allow that device to restart, to recycle, to start back over. But that's what the customer's saying, it's not working. So that ground state is technically, it's stopping the what would you call the zero startup or the initialization to not occur again. It should initialize.
Now, I understand what you're saying. However, that's not the problem. Right now, you get it wrong at 18, and the 18, how many wire here? Okay, nothing to do with the power on the ground. Normally, some people try to do it, turn off the power and turn on again. Try to reset everything and try to run it. But that not mean they can fix the problem. You get input and try output it wrong. Only deal with the U5, not the system. Don't try to make it more complicated. Very simple. You take input and take output, if they're not the same, something must be wrong. And this I say very simple thing. Pin 1 and 19 must be 0. And 18 is not logic 1. Normally you change the U5. If you change U5, they're still not working. What I think it may be when they soldering 17, 18 tied together. Then they have to fix that. Okay, I telling you the way testing for digital binary. How come I say that 0, 1, 0, 1, 0, 1, 0, 1? Then I must testing opposite 1, 0, 1, 0, 1, 0, 1, 0. That make sure on each line they must be tested for logic 0 and logic 1. If they tie together, they will be failed. Or they sorted to round, they must be failed. That is basically testing for digital. Each line input output must be testing for 1, 0, 1, 0, 1, 0, then 0, 1, 0, 1, 0, 1. They can be this cover on of the drawing in here on the whiting.
And Mr. Pham, but what you just said, I thought that get checked way back at U2.
U2.
Yeah, what you saying, remember how you just, right now, how you just said, I mean, U1. Remember how you said you check for 0, 1 and so forth for each wires, and so you can see if it's handling logic 1 and logic 0, what you just said. Well, I thought you start that off at U1. That's the reason for doing that little loop at the beginning, right?
Now, the thing is, U1 you already tested.
Correct.
U2 you already tested.
Right.
U3 you already tested.
Right.
So don't worry about U1, U2, U3.
So why were you pointing to U4 when you say you got a test for 0, 1, 0, 1, 0, and then flip it around 1, 0, 1, 0?
No, that's normally what I saying. Any digital input must be testing for 0, 1, 0, 1, 0, 1, 0, 1. Then 1, 0, 1, 0, 1, 0, 1, 0. That means each line must be testing with logic 0 and logic 1.
Okay,
That prevent, if they tie together, they will be failed. If they
Gotcha.
tie together, you testing on logic 1, you never know. Or you testing on 0, you never know.
Mhm.
The thing is, 11 and 12 tie together. If you testing on 1, then you get on 1. Or you testing on 0, then they still get on 0. However, if you test 1, 0, 1, 0, then line at 1 will be go to 0. That's why they fail. That is the way for testing in binary. Every input, output must be testing each line with logic 0, then must be logic 1. Okay, the thing is next week, we start register for you guys. Okay, so I'm working on that, try to assign get the access code for everyone ready.
Is that on Monday?
Yeah, from Monday to Friday. Everything must be done. Now, next week, the thing is 13. After next week, Monday will be start with the summer 2022. So next week will be a very busy to me. Also, on Wednesday, I have to go to surgery for my dry eyes. 2 weeks ago, I did it for my left eye. Next week, I doing for my right eyes. There'll be a lot of work. Report last semester for spring. Prepare for next semester summer. A lot of work. Okay, so I hope after today you're able to get through your test program. Not a problem.
Hey, Mr. Pham, you're gonna put this on the web real quick, right?
Yeah. Okay. So any question, anything? Otherwise, good night.
Good night, Mr. Pham. Put it on the web tonight.
Okay, I do. Any student stuck on the Form 20, start for 2020, you're hitting to the only big problem is your lab. Okay, try to working on that in the summer. You already get to AC, you don't worry about anything. Until when I start the RF section, then you can be in the meeting. Okay, good night, everyone.
Good night, Mr. Pham.